Hello everyone, welcome to my newest video on how to represent numbers in binary. Let's get started. So everyone wants to know, what is binary, right? So binary is a way to represent numbers, any form of number, in ones and zeros. Binary is used for computers, for adding, subtracting, multiplying, dividing numbers, as well as other things. So let's get started on how to read binary in terms of a decimal number. So binary is based on something called gray code. What is gray code? Gray code is a form where numbers are represented using something called 8421, in which each of these numbers represent a power of 2 starting from the right at 2 to the 0, 2 to the 1, 2 to the 2, and 2 to the 3, hence why each one is equal to its power. So 2 to the 3 is 8, 2 to the 2 is 4, 2 to the 1 is 2, 2 to the 0 is 1. So let's do a quick example. Let me just go ahead and so each of these powers are a power of 2 starting from the right. You start 2 to the 0 all the way to infinitely many numbers. So this is called the leftmost bit, or the least significant bit, sorry. And this is called the most significant bit. There's a reason why they're called most significant and least significant, but I'll go into that in another video. So this bit position is called bit 0 because in computing you always start with 0 and will make your way up. 3, bit 4, and bit 5. So these numbers are also equal to 32. 2 to the 4 is 16. 2 to the 3 is 8. 2 to the 2 is 4. 2 to the 1 is 2. 2 to the 0 is 1. Excuse me again. So next we're going to go ahead and do that example using this gray code. So given a decimal number 7, and this is base 10 because it's decimal, convert to binary. Okay. So the first thing that you want to do is find out what its highest power of 2 that can be that the number can be represented without going over. So what I mean by that is, within the gray code, find the bit position where you represent the number not on its own but without going over. So for example, I said 7, right? So bit position 2, you can represent it because it has a 4. And if you can't do bit position 3 because it's 8. So So if I was to write this down, I would put a 1 wherever I can represent it. So this is bit position 2, so I could put a 1 here. And you can't represent it with bit position 3, so you could put a 0. But you wouldn't really necessarily need that. The next number, you would have to basically add to 4 in order to get the number that you're trying to convert to. So 7. So in this case, we can use also bit position number 1 because it's 2. So 4 plus 2 is 6. So then I could put a 1 right here. And now we just need a 1 because 6 plus 1 is 7. So 4 plus 2 is 6 plus this one right here, so 1. So this is actually your answer in binary or base 2. So you could also write this as, you can also write this as 1, 1, 1, base 2. Usually whenever you're representing binary, you usually have 4 bits, but it's not that significant. So next, what I want to do is represent a binary number as a decimal number. And how do you find that out? Let's say. So let's say you have given the binary number. Let's do a high one. So given the binary 0, 1, 0, 1, 1, 1, find its decimal representation. The first thing that I'd like to do in this case is write this number down. So 0, 1, 0, 1, 1, 1, and this is in binary base 2. So the next thing I would want to do is write the gray code down underneath it. So starting on this side, so 1, 2, 4, 8. The next power would be 2 to the 4, which is 16. The next one is 2 to the 5, which is 32. Okay, so we're trying to convert this binary number into a decimal number. So the next thing that you should be doing is figuring out where there's a 1. Okay, so wherever there's a 1, whatever that number is from the gray code, you add it. So plus 0 because there's nothing here. It's nothing here. There's a 4 right here. Plus 4. Plus 2. Plus 1. So 16 plus 4 plus 2 plus 1. That is 23. So 23 is our number in decimal. Alright guys, thank you guys for watching. It's my first ever computer engineering video. Let me know if you guys like it. Thank you guys and subscribe.